So maybe we'll just start. Welcome everyone. Good afternoon. My name is Xuemai Bai, for those of you who don't know me, and I'm a professor at Fenner School. So before I start, I would like to acknowledge and celebrate the traditional first Australians and on whose traditional land we're meeting today, and pay my respect to their elders, past and present. So, I should start. So today's seminar will be a duo with myself and Steve Lade. And we'll be basically talking about our work with the Earth Commission, which Steve will tell you all about later on. And basically, this is based off two papers that either recently published or in press. The first one is a paper published a couple of months ago in Nature, which was led by Johan Rockstrom. And both of us are co-authors of that paper. And the second paper is a paper I led, which is in press with Nature Sustainability right now, which is about translating the safe and just Earth system boundaries. And for that, Steve also is a co-author on that paper. So we'll start with Steve introducing the safe and just Earth system boundaries. So Steve is a future ARC Future Fellow at Fenner. And I think he got his PhD from ANU, right?
That's right.
Yeah, a couple of years, several years ago. And then he spent some time, several years at the Stockholm Resilience Center as a research fellow. And over the last 3 years, he has been a key person supporting this Earth Commission from, mostly from the science perspective, and a key person in the Secretariat of the Earth EC. And I think from the next phase, you'll become the Earth Commissioner. So I think without further ado, welcome, Steve.
Thank you, mate. I'd also like to acknowledge the traditional owners and pay my respects to their elders, past and present. As Xuemai said, this work is an output of the Earth Commission, which is an international team of over 60 scientists. Xuemai was a commissioner in its first phase. You can see her face up there next to expertise very appropriately. Both Xuemai and I will be commissioners in its second phase. Xuemai is also the lead of the working group on translation methods, and the Secretariat of the Earth Commission is hosted by Future Earth in Sweden. Some of the challenges that the Earth Commission is trying to address include, we have the 1.5 to 2 degree boundary for climate change, which is catalyzing action around the world, at least partially. What are equivalents of that 1.5 to 2 degrees for other domains of the Earth system, for biodiversity, water, nutrients, and so on? When setting those boundaries, how can we account for impacts on people? And once we have those boundaries, how do we make them operational? How do we actually use them to drive change? Just to repeat the outline that Xuemai mentioned, I'll start off by talking about the Safe and Just Earth System Boundaries paper. Xuemai will then talk about the translation work, and then we'll finish off with a brief outlook to future work through Xuemai's laureate and my discovery. Just to say that although the things we'll be presenting here are mostly published, they are still very much a first attempt. You might find it provocative in some ways, I hope so. We're very open and welcoming of constructive feedback. So this is the paper, Safe and Just Earth System Boundaries, that I'll be talking about. The main result of this paper is that we identified 8 safe and just Earth system boundaries, or ESBs for short, that are grouped into 5 domains. Those 5 domains are climate, biosphere, the water cycle, nutrient cycles, and aerosols. We chose these 5 domains because they cover the big important Earth system processes, such as the water cycle. All these domains are threatened by human activities, and also changes in them will have impacts on people on policy-relevant timescales. So we have just boundaries and safe boundaries. The safe boundaries are set from biophysical considerations. Within safe Earth system boundaries, the resilience and stability of the Earth system should be maintained. In terms of identifying what these boundaries are, it was very much an inductive approach. We didn't have some universal method across all 5 domains, but we ended up with 2 broad groups. One of them was a multiple elements approach, which worked for climate and biodiversity, where we were looking at multiple different elements of that system, such as multiple climate tipping points or multiple ecosystem services. And we looked at the spread of key thresholds for those elements and identified boundaries from there. In the case of water and nutrients, we took a spatial aggregation approach where we started off with local boundaries, for example, the concentration of nitrogen in water, and scaled up from that to global boundaries. For just boundaries, generically speaking, the way we did that was to first of all look at the safe boundaries that we'd already identified and assess whether those safe boundaries are just from the perspective of interspecies, intergenerational and intra-generational justice. If they're not just, then we estimated a separate just boundary for avoiding significant harm. And by significant, we mean severe and irreversible harm. And then the more stringent of the safe or the just boundary is then the safe and just boundary. Of course, any justice scholars will likely complain that harm is just one component of justice. This is the broader Earth System Justice Framework that we were working with. The elements that are in this paper that we're talking about today are only those ones outlined in blue. Other elements of justice include procedural justice, distributive justice, and access to resources. You can read more about this broader Earth System Justice Framework in this paper, which came out last year, and another paper which focused specifically on the question of having sufficient access to resources in that bottom one there, which was out in 2022. So now I'll go through those 5 domains one by one and tell you about the boundaries in each of those domains. Starting with climate, because this is probably the most intuitive one. The safe Earth system boundary we identified there was 1.5 degrees to avoid high likelihood of triggering multiple climate tipping points. The main evidence base for this boundary was the assessment of climate tipping points that was published by Armstrong and Kai in 2022. You can see one of the key results from his paper on the right here. You've got a bunch of climate tipping points here on the x-axis and the ranges of which they might be triggered on the y. And that you can see that starting at about 1.5 degrees, we start to get into high likelihood of triggering multiple of those tipping points. We also took account of past climate variability and biosphere and cryosphere function when we set those boundaries. And you'll note that that 1.5 happens to align with the Paris Agreement. However, at 1.5 degrees, we're probably going to have significant harm to hundreds of millions of people worldwide. We came to that figure from looking at extreme heats. There's climate niche work that shows that mean annual temperatures over 29 degrees will likely render that region unlivable. Wet bulb temperatures, which account for humidity, we looked at more than 35 degrees for at least 1 day per year, and then also impacts from sea level rise. And you can see that on most of these metrics, we're hitting hundreds of millions of people exposed to this harm by 1.5 degrees. Whatever your definition of justice is, that's probably not just. So we set instead a just boundary for climate at 1 degree. And therefore the safe and just boundary is also at 1 degree. So this is one example of a good example of the difference between a boundary and a target. By setting a boundary at 1 degree, we don't recommend that the world tries to get back to 1 degree, considering we're already at 1.2, nearly 1.3. That transition to get back to 1 would itself probably be unjust. By setting the boundary at 1 degree, we're just highlighting that we're already in a world with large amounts of injustice from climate impacts. And if we don't stop emitting soon, it's going to get even worse. Now, onto the biosphere. We have 2 boundaries for the biosphere. This first one, natural ecosystem area, is relevant at very large scales. It says that at least 50 to 60% of the global land area should have largely intact natural ecosystems. This is to provide essential ecosystem services at the regional to global scales, such as carbon sequestration, maintaining regional water cycles, and reducing species extinction. This is based on some modeling studies. It happens to be consistent with the 30 by 30 goal that's in the Kunming-Montreal agreement, which is restoration of 30% of degraded lands by 2030. This boundary is a safe and just boundary, but we do note that spatial distribution of this intact area across the world is going to be critical to justice. Now, moving on to functional integrity. This boundary says that every square kilometre of land should have at least 20 to 25% semi-natural elements in it. This is to maintain local ecosystem services. So it's a local complement to the global one on the previous slide. It's relevant for managed nature, so things like agricultural landscapes, urban areas, and forest plantations. 20 to 25% is quite ambitious, as I can see from Jack's reaction there in the audience. Below 10%, so the 20 to 25% is what you need to get all ecosystem services. If you drop below 10%, then all of them will be lost. So you've got a transition range there in the middle where you pick up some more.
I was reacting to just the every kilometre square.
Okay. Yeah, exactly. The evidence base for this was a systematic literature review of the area and configuration required for different ecosystem services. You can see the list there. Moving on to water, we again have a pair of boundaries. One of them is for surface water, saying that there should be at most 20% alteration of monthly flows in any river or catchment of the world. Alteration means either increase or decrease. And for groundwater, we set a safe boundary, safe and just boundary, that the drawdown from groundwater aquifers, including both natural and human drawdown, should be less than the annual average recharge. These boundaries are to protect freshwater ecosystems, including groundwater dependent ecosystems, and to maintain the services that they provide, such as drinking water and fisheries. Alterations most intuitively comes from direct extraction of water, but could also come from dams and other alterations to river flows. These are presumptive boundaries in that they're to be used in the absence of local assessments. We're a little bit spoilt in this country that we do have a lot of environmental flow assessments, but much of the world does not have those. You'll also note that this boundary is mostly about water quantity. Water quality is going to be addressed at least in part by the next set of boundaries. Which are the nutrients boundaries? So again, here we have two, addressing nitrogen and phosphorus. Use of nitrogen and phosphorus in fertilizers that is not taken up by crops and is therefore surplus, can get washed into rivers and lakes and becomes a big environmental problem. They're relevant for the safe boundaries, the biophysical boundaries, because it can lead to eutrophication and breakdown of freshwater ecosystems. There we started from some well-established local concentration boundaries for N and P in surface water, and also for N deposition through ammonia in terrestrial ecosystems. We then use modelling to convert those local concentration boundaries into local surplus boundaries, and then aggregated those into global surplus boundaries, ending up with the two boundaries that you can see here. From a justice perspective, the impacts on people of that eutrophication is going to be significant. But in a more direct route, there can also be harm from drinking water with a higher concentration of nitrates in it. That leads to another boundary. Once we incorporate that extra boundary, we end up with a global surplus that is slightly tighter than the one accounting for eutrophication alone. So nitrogen is another boundary where accounting for justice leads to a tighter, safe and just boundary than the safe boundary alone. And finally, aerosols, air pollution. From a biophysical perspective, air pollution can change weather patterns, potentially even monsoon patterns, which would obviously be quite serious. We have a few boundaries here. We rely on some previous work which sets a regional aerosol concentration at 0.25 AOD, aerosol optical depth, which is a measure of aerosol concentration. Some recent research also shows that the difference in aerosol concentrations between the northern and southern hemispheres matter. That can affect global circulation patterns. The maximum difference should be 0.15. Of course, air pollution also has massive impacts on human health. It's estimated to currently cause 4.2 million deaths per year around the world. We take a boundary from the World Health Organization of 15 micrograms per cubic meter of PM2.5. When you convert that PM2.5 figure into aerosol optical depth, you end up with 0.17, showing that aerosols are another case where justice considerations lead to a stricter boundary than biophysical considerations. So those are the safe and just Earth system boundaries. Have these boundaries been breached? At the global scale, yes, 7 out of the 8 have been. For climate, we're at 1.2 compared to the 1 degree safe and just boundary. For intact nature, we're at around 45 to 50% global intact area compared to the 50 to 60% boundary. The functional integrity boundary has been breached for 2/3 of human-dominated land area, surface boundary for about 1/3 of global area, the groundwater boundary for about half. The nitrogen and phosphorus uses at the global scale are about double their respective boundaries. The only one that has not been breached is that interhemispheric AOD difference that I mentioned before, which is at 0.05 compared to 0.15. That was at the global scale. At the local scale, many boundaries have also been breached. So this figure shows, this heat map shows the number of boundaries that have been transgressed locally in each pixel of the world. At least 2 of the subglobal boundaries have been breached for about half of global land area, but about 85% of global population. So that shows that transgressions, environmental impacts tend to occur where people are. And just briefly, how do these results and this framework for Earth system boundaries compare to other frameworks? You might have heard, for example, of the planetary boundaries or of the Donut Economics by Kate Raworth. You can think of the Earth system boundaries as a deep dive into a subset of the planetary boundaries to, first of all, identify safe boundaries at operational scales for assessment and management. The planetary boundaries are at planetary scale. The safe and just Earth system boundaries are set at smaller scale, for example, the catchment, or even the square kilometre scale. That's going to be more useful for assessment and management. The evidence base is also a little bit different. The ESBs work at least in part off tipping point assessments, whereas the planetary boundaries work off Holocene variability as their key evidence base. We also incorporate justice through the just boundaries for minimizing significant harm. Critically, we do that in the same units as the safe boundaries. This is different to donut economics. And also, these boundaries are a purely scientific assessment without any concern for feasibility, as you saw in the climate boundary, for example. This is unlike the sustainable development goals, the Montreal Agreement, and so on, which are politically negotiated. And with that, I'll hand it over to Xuemai.
Thanks, Steve. Okay, so once we have identified the boundaries, it is really important that we translate that, connect that to actors so that people can take action, so that our society, as a whole can move towards this living within the safe and just boundaries. So they really need to be connected to actors and then, guide practice. But first of all, what do we mean when we talk about translating these boundaries to actors? So there are 2 kind of cases we can think about. As Steve said, most of the boundaries are already transgressed, right? So in those cases, when the current position is beyond the safe and just Earth system boundaries, that means what we need to do is we need to translate the actors' share of reduction responsibilities. So there's no, resources or those sort of things that we can share. What we need to do is really share the responsibilities of reduction. So, and then how to do that equitably. And in those not transgressed ESBs, sometimes global or local, what we probably can do is the actors can share the resource budget equitably. So in this case, we can see the safe and just boundaries are above the current sort of position. So most of the global boundaries were Steve just said this is this case, but for some or regional boundaries, there are many cases like this one. And we think engaging cities and businesses is particularly important. And this is not only because I'm biased, because I mostly work on cities, but also because of their impact is really large. If you look at cities, over 75% of all the GHG emissions, consumption-based GHG emissions can be traced back to cities. And if you look at companies, there's a research that shows over 90% of all environmental impact are sort of generated by some kind of value-added activities, and many of them are conducted by the companies. So translating these ESBs and then connect them to actors and then to their target is a crucial way to stop these cities and companies from causing planetary harm. So by translating these Earth system boundaries to actors like cities and companies, that can help them to set science-based target. I mean, we know many cities and companies, they do set some kind of target for their environmental, as an environmental goal. And we do know that this particularly science-based target really works. I mean, science-based target means, when we aggregate all those targets globally, then, the aggregated value will be staying within the science-based, within the Earth system boundaries. That's what we mean by science-based target. So we do know that this science-based target actually works. So this figure, this is from the paper we published in Nature, I think it was 2 years ago, talking about the cities and businesses. So here, from this figure, you can see this target, this medium line here that shows the national pledges to Paris Accord with the 182 countries. And this line here shows companies that do have some kind of environmental target, but probably less stringent kind of target other than science-based targets. So they are about here, maybe about 3 degrees, something like that. And then if we look at, but anyway, if we look at the companies with science-based targets in terms of climate, then we can see they are really aligning with a 2 degree or 1.5 degree target of Paris Agreement. So you can see the national pledges are the least ambitious one, whereas the science-based target by companies, they are the most ambitious ones. But in order to set this kind of science-based target, we just talked about translation is important, but there are many knowledge gaps in terms of cross-scale translation. For example, there's no common procedures. Each different companies, they're doing their own things differently. And very, very little focus on interactions. Usually they just focus on one particular domain and then set target on that particular domain without considering the impact on other domains. And also many of these target setting is not really acknowledging the dynamics over time. And also just and equity considerations vary across different cases and different cities or companies. And there are very little support for monitoring and accountability of how they are actually sticking to their pledges and goals. And there is no governance sort of mechanism to support them, because many of these kind of target setting, science-based target setting, it's voluntary kind of approach. So it's entirely up to the actors themselves. And it is really important to design incentive structure, for example, like tax incentives or more favorable investment conditions, things like that. And these things at this moment are very just emerging, and it's not really mainstream. So the Working Group 5 work, which I've been leading over the last 3 years, has been trying very hard to fill some of these identified gaps. So one of the first steps we have done is try to develop a common sort of principles of translation. So what sort of principles, if a translation follow, then we can say, okay, this is the right kind of way of doing it. So we identified 10 different principles. The first one is it needs to be, for example, scientifically rigor. The approach and application needs to be consistent, quantitative, and can be, repeated. The methodological steps are really rigorous and clear, so that it can be duplicated. And the second one is it needs to be transparent, because these translation steps usually involve many different steps. And if you look at the literature, it's not exactly clear how each steps what sort of steps are followed and how they are done. And I think it is very important to be really transparent about what kind of assumptions and what kind of steps you have taken to derive at your target. And the third one is it needs to be just. Just consideration is really central to this, but again, this step is very often sort of treated as implicit kind of assumption without making it clear. And then the other ones, for example, needs to be systemic, and there are several more you can see, but I would like to mention this sufficiently safe, because I do get questions about this a lot. What we mean by sufficiently safe is that we do know any target or any goals, there are some people or some actors who will be failing meeting them. So we think it is very important from the very beginning, we introduce some sort of buffer, like 20%, for example, so that we can account for those laggards, for those who eventually might fail, so that even some of them fail, we still can ensure that collectively we're staying within these Earth system boundaries. And here, this figure shows several different steps that a translation can follow. Usually we have the safe and just Earth system boundaries, but they are the state of the Earth system. This needs to be transcribed into the budget or standard at the act level. For example, if we say less than 1.0 degree warming, what does that mean in terms of total global carbon emission, right? And if we say annual groundwater drawdown less than average annual recharge, what does that mean? In terms of volume of groundwater that can be extracted by anthropogenic activities, and so on. And then this kind of transcribed budget then will be translated into different actors through initial allocation of budget and responsibilities to cities and businesses. And then eventually they arrive at the translated budget. And this kind of translated budget at actor level, they can be used for different purposes. For example, for reporting, or for benchmarking, or for risk management of actors, or science-based target setting. And this will be a reiterative sort of process. And this is another way of slightly different way of showing these key steps of translation. Here you can also see how the developed 10 different principles actually speak to different steps of translation. As you can see, the sharing approaches are really key in terms of carrying out the entire translation process. So here we have reviewed 40 studies which actually conducted translation through different domains and through different scales. And here is the result of this review. So from here you can see, I think most of the translation was conducted at country level, which is the blue dot, and some conducted into, for example, cities, which is very, I think just a couple of very, very small number of them. And some of them conducted, translated into sector industry, and some of them translated into companies. So from here you can see some clear pattern. For example, different sharing approaches like the legacy-based or grandfathering sharing approaches, or basic needs or preference, or equality or economic contribution. These are some of the sharing principles that are most commonly used in these studies. And then the approaches, for example, like resource efficiency or green incentives, or sovereignty or development right. These kind of sharing approaches are rarely used in existing studies. So these kind of sharing approaches are applied in different ways across different scales. So this figure shows a typology of this cross-scale translation, how these kind of different sharing approaches are used to derive the eventual end point of actor budget. So on the A, it shows you can do this translation just across one step, one scale, and then using one single sharing approaches. But B shows often these translations have to go through several scales with several different sharing approaches. No, B is using the same kind of sharing approaches across different scales, but C is sometimes you have only one step, but you have to use different combination. And then D is several scales and then several different combination of sharing approaches. And this is important, especially for cities and companies, because usually in order to be translated to cities, you have a middle point at country level, for example, or if it's company, then the midpoint will be very often sectors. So there are multiple sort of scales involved. And even after the sharing approaches are defined, what particular sharing approaches you are going to use, how to use them, again, influences the outcome. For example, the system boundaries in translation really matters. One of the way of looking at approaches would be the bioregional perspective. For example, sharing the local boundaries among the people and economic activities within the basin, for example, if it's green water, for example, blue water, for example. And another perspective would be a global citizens perspective, where the global total budget for anthropogenic consumption can be shared across the whole world population equally. So I'll give you one moment to register these two different perspectives. But there are issues with this bioregional approach, because there will be a very clear pattern of winners and losers depending on the natural endowment. For example, if your country or your city is located in a basin that has abundant water resource, does that mean you can use as much as you want? Whereas in another basin where there are a large population living on a very small water resource endowment, they can have only very small share. Is that really just or not? And the second one is there will be unintended loophole due to this burden shifting, because even if your basin has very small water endowment, but if you are really economically have the capacity, then probably you can just import the e-water or imported water from other regions. Again, this creates a kind of loophole in terms of burden sharing. And also, it is inappropriate when it comes to sharing responsibilities. For example, we know Amazon region, for example, they have vast amount of biodiversity. But conserving this biodiversity, then, does this mean only those people who are living in Amazon area is their responsibility, while the benefit is really shared globally? So there are many issues with this pure bioregional approach. So in our translation, we really call for, we think the translating through a bioregional approach really needs to be accompanied, benchmarked, or adjusted by a global citizens approach to inform target setting and policy development. And we also say that actors should really strive to adopt the more stringent target between these two kind of approaches. So this is just one example of the many uncertainties and issues surrounding the translation. And this is one of our first step attempt to try to develop a kind of protocol of translation so that any actors, cities or company, if they are trying to do this translation, they know exactly what sort of steps they should follow. So here we think different Earth system domains might have different suitability for different sharing approaches. And then there are spatial construct matters, whether they are spatially globally constructed or subregionally defined, or they are grid-based. And then there are status also matters. Is it transgressed or not? And the regenerative nature of this particular domain also matters. For example, some of the domains doesn't have regenerative capacity, whereas some others do. For example, the forest or biodiversity one, probably it's a couple of decades you can restore, to some extent, quote unquote, with a bracket. But others, like climate, for example, they probably don't have this regenerative capacity by themselves. So unless we take them out or stop emitting, the situation wouldn't really improve. And then there's these temporal perspectives. Are we going to look back and then trace up the responsibilities of causing the problems we're facing now? Or we are going to adopt a more forward-looking approach, saying, okay, past this past, let's look forward to see what we can do. So all these really influence the choice of final sort of sharing approaches. And this will be really influenced by the equity and then the contextual issues of where you're conducting this translation, etc., those things. And after all this is fixed, you can finally have the choice of sharing approaches. And then, you can arrive at the allocated shares through translation.
That's 18 minutes.
So what I have learned from this practice is that there are many uncertainties and there are many value judgments involved. And then the translation is very often context specific, and justice really needs to be considered, taken into consideration. And then one interesting thing we have noticed through this exercise is the importance of cross-sectors, cross-domain sort of collaboration. And here we are highlighting the potential of leveraging on the co-location between big cities and big companies. So we know some of the largest emitter cities, some of them have net zero target, and they also host many top 500 emitter companies. So many of these companies located in these cities with net zero target, they don't have to target themselves. So in this paper, which is a spin-off paper, currently under review with Nature Sustainability, we quantified what will happen if those cities can actually reach out and persuade those large companies to also, address their target into the same level, and vice versa. So, and we identified actually there is a quite large potential in doing that. So that's about the translation. And now I would like to very briefly mention my laureate project, which was awarded this year. And the title is Cities as Transformative Agent for a Climate Safe Future. So this is very much related to the work we are doing within EC, because this is really emphasizing the agency of cities. So what we are trying to do is, by reconceptualizing cities as a transformative agent, we're trying to generate theories and empirical knowledge on the following three aspects. One is how cities actually evolve and transform, and how they can actually network to enhance resilience to climate impact, and what sort of governance innovations can set them onto accelerated pathways. And this one shows the conceptualization. So here's the cities. By using this kind of cities and transformative agent approach, we can really drastically improve the eventual outcome through their trajectories over time. And this is a 5-year project. It's going to start from next May, and I'll have 4 international case studies in Copenhagen, Tokyo, Shenzhen, and then Jakarta, and then several Australian case studies. So we will have collaborative networks in Europe, Japan, China, and Indonesia, and the international recruitment process for 3 postdocs and 3 PhDs, and 1 project officer will be commencing very soon. So that's it, and I'm hand back to Steve.
Thank you, mate. I just have 2 slides to finish off on my discovery project, which is about developing and applying an Earth System Impact, or ESI, score for businesses and investors. The challenge there is, suppose a business knows how much carbon they're emitting, land use in different areas, and water use in different areas. How significant are those environmental impacts for the Earth system, or material in business language? The Earth System Impact Score tries to answer this. It's systemic in that we're looking at climate, land, and water, so multiple Earth system domains, as well as the interactions between those domains. It's science-based, as Xuemai was referring to before, in the same sense, in that it weights impacts in these different domains according to their respective boundaries. It's also context sensitive in that the boundaries that we use depend on the locations of those impacts on land and water. This is an Earth system scale assessment. It's not a substitute for local environmental impact assessments. The data that we need to make the score work are emissions, water consumption and land use by location from an entity, say a company. These sorts of data will soon be standard reporting variables through initiatives such as the Task Force on Nature-related Financial Disclosures, the Sustainability Accounting Standards Board, and so on. In my discovery, the goal is to advance the scientific basis of and apply the prototype score, which is already published a couple of years ago. I've got 1 PhD starting next year and 1 postdoc advertisement that's hopefully live within the next week or 2. Here's one example application of the score to mining company data, which were extracted from publicly available reports. You can see here the mines on the x-axis. We've sorted the impacts by size. Earth System Impact Score on the left, split up into red, green, and blue for impacts from carbon emissions, land use, and water consumption. You can see that the mine with the biggest overall impact on the Earth system has its impact coming mostly from water, whereas some other mine, for example, this one about 12th or 13th from the left, has most of its impacts, almost all of its impact coming just from carbon emissions. So hopefully you can see how this might be useful to businesses and investors. Businesses could use this to say, for example, at this mine, we should be prioritizing reducing water use first, and investors can use this whole spread of data to make decisions about where they should invest to minimize their environmental impact. So to summarize this talk, this work on safe and just Earth system boundaries, some of the scientific advances include quantifying safe and just Earth system boundaries. In many cases, we find that the just boundaries are stricter than safe. That's the first time that finding has been made. Many of the safe and boundaries have, unsurprisingly, been breached both at local and global scales. We've also been developing methods, including principles and protocols for cross-scale translation of those boundaries to active targets. Our results are a call on businesses, cities, and society to factor in people, so address impacts on people as well as on the planet. We note that any action in light of these boundaries should itself be just. It's also a call to set science-based targets using appropriate translation methods. And we're also proposing to use an Earth System Impact Score to assess current impacts and potentially make investment decisions. That's all. Thank you. I think we'll now be open for questions.
many questions. I understand that it's a lot to take on. And
Thanks very much for that. I enjoyed that a lot. And it was nice to see both the science and the context around you both having significant new projects. So you both really emphasised the importance of boundaries and also scores being science-based, in contrast to politically derived. But I mean, many might say that's a bit of an artificial black one, that science is not without politics. So I guess it's can't phrase this exactly the question, but I invite you to comment on what does that process really look like? You know, when you're with a group of scientists, I don't really believe that everyone comes up with the same number all at once. So talk a little bit about the process from the science side, but also reflect perhaps on how it's just, if that sort of being science-based rather than political is being received in that light, or are people challenging from the point of view that everything's political?
Yes. Thanks, Saul. First of all, certainly agree that there's politics and science, and any assessment like this there's a lot of expert opinion that goes into it as well. The choice of the term science-based is deliberate, so that many of the science-based targets that companies set will have compromises built into them, the same as the SDGs or other global agreements. There will be an element of political compromise. The key factor is that there's some contribution of science towards setting what those numbers should be, rather than just an arbitrary, oh, we're going to reduce our emissions by 20% next year without any idea on whether that's enough. So the science base is really about providing some science there to help evaluate whether actions are enough. You want to add, Xuemai?
yeah, I think to your first part of the question, I think excuse me, I don't know what's wrong. Our approach is really based on published literature, basically, and then you know, expert elicitation. And there are, of course, different opinions. And I believe, for example, the water boundary, a group of experts, I think they are challenging, you know, some of the, you know, standards and why you have used these particular boundaries and not the other one. And then I think the water group has provided, you know, counter sort of argument to that. So yes, there are disagreements and contention and everything. But I think the fact that it has passed the really strong and rigorous review process within Nature, and then our next paper, which is on the second round of review and response with the Lancet Planetary Health, that has how many reviews? 10 reviewers or something? 6, 10, somewhere between 6 to 10 reviewers. And I think the overall consensus is that it is scientifically sound, and you know, people now agree that this is something
I
that
suppose my
can.
question is not so much about whether or not it's accepted as scientifically sound as the scientific community, but when it goes out in the world and has the influence we want it to have, if you have any reflection on how the political response or the sort of governmental responses to this deals with that concept of being scientifically based.
So the science-based target already has several initiatives going on, science-based target initiatives, and then science-based target networks. There are 2 organizations, and then they are having increasing involvement of companies and cities. They are, you know, signing up, and then say it's all voluntary, by the way, at this moment, saying we do want to have this science-based target, but we don't know how. So they are reaching out to these 2 organizations to try to help them to you know, operationalize this kind of things into their science-based target. So there are increasing recognition there.
Thanks.
Also, the distinction between the 1.5 to 2 degree boundary for climate, which is now well established, and things like net zero by 2050, which is emerging as more a political target. That's another interesting example of where the scientific boundaries and the targets are close, but not exactly the same. I mean, there's a lot of flexibility in how we get to 2050, which might mean we blow well past 2 degrees. Yeah.
I think a presentation was quite thought-provoking development. The first one, when you mentioned the definition of, say, boundary and just boundaries, the thought that I had in mind was about agronomic kind of zone in Brazil. And I was just thinking, well, what does it mean in terms of impact system, and what does it mean in terms of how in fact you can influence a little bit governance systems through using this kind of setting. The other thing that I was thinking was about the targets. And I was thinking, well, targets were, I will say, set, because we were kind of thinking we can predict things. But when thinking in the long term and deep uncertainty, what does it mean in terms of setting these targets? And in terms of adapting these targets, give them that flexibility where we can actually readjust according to how we are moving. And it won't become, in some instance, an incentive to continue to pollute and reach the boundaries of the system if we are on the trajectory. And lastly, I was thinking about the transfer. So most of the companies and the countries are producing outside their boundaries. So what does it mean in terms of influencing their contribution to, say, and just emissions or whatever it is? Yes, so that was the type of thought that I have when you went to.
So let me try to recall. I think the first one is, how do you actually influence the government and actors to actually do that? I mean, we are scientists, right? What we can do is really try to publish high quality and high impact kind of scientific result. And then to some extent, we hope the world can take notice. But we're not only doing that. For example, the Earth Commission, the upper level body is
Global Commons Alliance.
the Global Commons Alliance. And within that, we do have the Science-Based Target Network, also the Systems Change Lab, which is really actively trying to reach out and influence the governmental actors and other actors as well. And for example, like the World Economic Forum, they're very, very much interested in this idea. And then they have invited, some of us to go to do, plenary presentation in their Davos and Summer Davos conference. And, the World Economic Forum, this is a very high level kind of platform. So through influencing those sort of, influencers in the world, I think we would like to have our intended sort of impact. And let me come to the last question was, yes, it is very important, I think, point. And we do emphasize in our paper, the translation paper, that it is very important to try to use both the production-based and consumption-based. Whereas if you use consumption-based, of course, you are tracing your impact throughout the world. But exactly how you can actually reconcile this production-based, accounting and consumption-based accounting on the same page is still a remaining sort of challenge. So we do acknowledge the challenge, and then we think this is something that we need to resolve going forward. And then the second question was?
Yeah,
Yes.
I can fill in with a couple of things. You also mentioned agroecological systems there at the start. So we didn't, I didn't carefully define on the functional integrity boundary what semi-natural, if we get back that far, semi-natural ecosystems mean. It is the intention that things like agroecological farming systems would, if they have enough semi-natural ecosystems in there, they would likely satisfy that to a 20 to 25% boundary. So it's not as if we should have like virgin wilderness in every square kilometre of the land, but rather we should have some kind of functioning ecosystem in there. And in terms of deep uncertainty and adjusting targets, I think that's another point where it's good to come back to the difference between boundaries and targets. So the boundaries are the scientifically determined reference points. A good target should take into account things like, first of all, capability. How capable is a particular area how capable are they of reaching a particular goal? maybe less capable areas should have a slightly less ambitious goal to be compensated by other areas, and it should be something that could be subject to adaptive management as well. I note that we are now at 2 o'clock, so perhaps we should say that for those who want to or need to go, you're welcome to. For those who have more questions, I'm certainly happy to stay a bit longer, and Xuemai too, if you have further questions. Thanks.
I've got a couple of questions from online.
Yep.
So we've got one from Roxana asking if you could please further describe the BSI score, the types of business where it's piloted in, and how it quantifies specific metrics. Is it similar to life cycle analysis thinking?
Thanks. So that one's to me, I guess. So the Earth System Impact Score, it's very much at a prototype at this stage. The only test case so far has been that mining application study, that mining study that I showed you before. So that's the only case where it's been applied so far, that mining case study. Life cycle analysis, our life cycle analysis could produce some of the data that you would need to feed into the impact score. So I see this sort of score as complementary rather than replacing. So you could use life cycle assessment to evaluate all the various climate, land and water impacts upstream and downstream of the particular actor you're looking at and feed that into calculating the score as well. Hope that answers the question.
And the other one I've got from online is from Tracy, asking what could be some useful incentives to encourage businesses to set such science-based targets now rather than later.
I'll leave that one to you.
Yeah. Well, I think one of the possible incentives is, for example, like if they can get more favorable, for example, investment conditions. And some of the banks, I think it was in Denmark, they are practicing that kind of, standard, saying if you do have this sort of science-based target, you probably get more favorable loans, for example. But I think the biggest push might really comes from the public. Once this sort of information has gone out to the public, and then people start to accept the ideas, I think the pressure coming from the, the general public, the consumers, would really push the companies to change the gear. And I think that probably is the biggest sort of, force for this sort of change.
I guess question to Steve about your mining example. Just trying to work out, could you possibly get, sorry, it's your last but one.
Yeah.
But the whole presentation, I think. Right at the end. Yeah, there we go. Well, both in terms of novelty and in terms of how much difference it might make at the company level. How does your index compare to lots of other biophysical indexes I've come across? I mean, whether it's ecological footprints or environmental sustainability index, etc. I mean, there are lots of other indices out there, lots, about a handful of major ones that add up different physical impacts and try and sort of put them in index numbers. So I'm wondering what's really different here. And then also, rather separately, I'm wondering how much difference would it actually make at the internal company level? I can sort of see that an overall index is useful for investors who don't have the time to look inside detailed company accounts to get some kind of composite view. But I would have thought that in terms of actually changing company action, it would be more down to individual regulations on those three different things, for example, and how that affects what the company directors decide to do. So.
Sure. Thanks, Jack. So to the first question about how this compares to other composite metrics, I'm certainly not familiar with the full range in that space, so I welcome references to specific ones, so I can compare them. Well, one of the key elements here is that we are scaling impacts in each domain by the planetary boundaries. So that provides a reference point for what constitutes significant impact. I think that's a key difference. Another difference with,
I mean, rather than sort of going for a common scale like ecological footprint, was saying, well, just adding up equivalent land area isn't the right way to look at it when some of the domains are much more constrained than others by planetary boundaries.
Yes, exactly.
Oh.
Yes. So if you're just looking at land impacts, then you could use a footprint to add up all the land impacts. But if you're comparing land against water, you need some reference point to compare those two. Another thing that we do here, which is quite new, is that we also look at the, which I didn't talk about much, the effects of interactions of pressures on one domain on another. So if you clear lands, that will have impacts on the land variable itself, but also on climate through embodied carbon, also on water through changes in water runoff. So that's a new thing. In terms of differences between internally motivated in environmental mitigation versus externally imposed through regulation or pricing. This comes up as well in the context of science-based targets. Why should companies do this voluntarily? I guess action ultimately is going to have to be a combination of both these things. To get effective regulation through government, you probably want some level of support from businesses for that to happen. There are companies who are leaders in this space who will be taking these sorts of decisions by themselves for reputational reasons or intrinsic reasons. If there's something like an ESG, this ESI score gets implemented for investors, that would be another reason for companies to reduce their environmental impact overall. Would you like to add anything, Xuemai, on voluntary versus?
Yeah, I think one of the business really said it very clearly when I was attending one of the World Economic Forum event. They were saying this sort of things is no longer an issue of compliance, but it's an issue of risk management. To manage your future risks, it could be reputational risk, it could be regulatory risk that kick in later on from the government. So the companies, especially those front runners, they are really looking at it from one step ahead and then see what sort of things are going to come and how we are going to respond that in terms of from risk management perspective. So I think that was in a way that sums up quite clearly why these companies would really like to look at this and then take the voluntary actions. If any more questions? If not, then we will close this.
Sorry, I do see a raised hand in Zoom from your
Oh.
AS. Are you getting that, Moss?
I'm sorry, can you hear me?
Yes, faintly. I'll just try to turn up the volume. Yes, go for it.
Okay, I'm sorry. I was unable to type using my hand, so I'll thank you very much for excellent presentation. The fact that you covered all the assessment and then translation, which was fantastic. I have a couple of questions. The first one is, to what extent is already entrenched injustice or harm considered in the measurement? And is it important to consider that in terms of assessing the sort of injustice that might have happened already, committed because of the harm that has happened already? Well, I'm asking two questions. The first one is that this one just looking forward and probably not accounting what might have happened already, and whether that injustice is important, that harm is important to be considered in the measurement. The second one, Rami, you said that one of the principles that for translation that you outlined, you heavily emphasized about the quantitative based, science-based approach for the translation. One of the challenges that we face is that overall there is a lot of growing skepticism about science, and there is importance in terms of tapping to the emotional aspects of different members of society, and narratives and stories are very important. Qualitative approaches are very important. To what extent do you think is there space for allowing this type of approach to translation, given that the ultimate outcome of such an approach is really to convince people to do the right thing? Thanks.
Okay, I'll try to answer. I think whether to consider the historical harm responsibility, I think sometimes it depends on which particular domain you're looking at. For example, when you're talking about blue water resource, then because it's regenerate every year, so there's not too much point of trying to look back and then say what was the historical harm and things like that. But for indicators, for example, like CO2 emission, these are accumulating in the atmosphere and not really going away unless we take them out. So for those cases, especially that we have already crossed the boundary, we think probably it's more appropriate to use some of the backward-looking backward-looking and the historical responsibility type of principles, and then allocate the reduction responsibility in that sense. So I think it really depends on which particular domain we are looking at, and the choice of this sharing approach is actually really up to the person or the organization or the cities who are actually conducting this kind of translation. There's no dictating sort of mechanism exists. So what we think at least is very important is when you do this translation, you make it very, very clear you are doing using what kind of approaches and using what kind of assumptions in your approach. So eventually when there are enough cities and companies adopt this kind of approach, and eventually when we try to aggregate them together, we know exactly how to aggregate. Because if we don't have the assumptions and approaches clear, there's no way we can add them up. So I think we are at that kind of stage, rather than really designing one particular set of method that one can pick and follow. So the second question was.
I just want to add to that intergenerational justice question from the perspective of setting boundaries as well. That is something that we did take into account, for example, in the climate boundary, the fact that actions today will have impacts on distant generations, particularly when it comes to melting of ice caps and sea level rise. So we did account for intergenerational justice when setting the boundaries. Thanks, Yaes.
Thank you so much for everyone staying this long, and yeah, thank you.